Good, good afternoon to all of you guys. Hope everyone is having a good day. So I will let me share the screen here. 1 second. Uh, um, Wait. Mm-hmm. Mm-hmm. Click, click. There we go. Is everyone seeing this okay? All right. So what I will, so Ethereum has changed a huge amount as a technology in the last 5 years, right? And I think one of the big changes that we're making as an ecosystem is basically this shift from being a, yes, very small ecosystem that's focused primarily on building applications for itself, making things that are difficult to use and require a fairly high skill level, fairly high amount of money to pay transaction fees, have all kinds of issues with them, to something that is really much more ready for large scale adoption. And this is happening in a bunch of different ways. And this is really relevant both to users that are considering using applications on Ethereum, and also to developers, right? Because the way that you build applications is changing a huge amount over the last few years, especially. So probably the biggest thing that happened over the last, like this year, is the Denkun hard fork, which introduced this concept of blobs, right? So blobs are a special segment of data space on the Ethereum chain where people can submit just raw information. The EVM cannot read it, but the data is there for layer 2 protocols. So layer 2 protocols can put their data into blobs, and by having blobs be this separate section of data space, it allows them to be much cheaper. It allows blobs to be extremely cheap, even if the rest of layer 1 becomes expensive. So since blobs came in, we have seen a massive reduction in fees on rollups. So Arbitrum, Optimism, Linea, ZK Sync, Base, all showing fees that are under 3 cents. And, this is a huge change compared to like even 2 months ago, right? 2 months ago, all these rollups are probably showing fees of around 10 to 20 cents. Now they are vastly cheaper. So huge amounts of improvements happening here that I think is really important to not underestimate, right? And like fees decreasing by this amount really unlocks a huge number of applications, right? Because if you think about just basic consumer payments, at less than 1 cent a transaction, that's something that actually becomes viable, right? But at 10, 20 cents a transaction is something that, especially for smaller value payments, really does not make any sense at all. So Ethereum is becoming a layer 2 centric ecosystem, right? So 5 or 10 years ago, if you were building on Ethereum, you were building on layer 1. Today, if you're building on Ethereum, then the thing that makes sense to do is to build on layer 2. Now, you might ask, like, okay, so there's Arbitrum, there's Starknet, there's Polygon, Optimism, Scroll, Metis, all of these ecosystems, and like, how do you even choose, right? Like, what does Ethereum even mean in this kind of world? And so the way that I think about this is think about Ethereum as being like a country, and think about the individual layer 2s as being like cities, right? So sometimes people on Twitter are saying like, oh no, people are migrating off of Ethereum and they're moving on to Base. And like, this is completely false, right? Because like this is basically like saying, oh no, people are leaving Thailand to go to Chiang Mai. So like basically think of each of these ecosystems as being like cities. So coordination within an ecosystem is very easy. Everything is very close. You can do instant, like synchronous transactions. You have excellent composability, but then you still have some level of composability, and particularly you have shared security between these different sub-ecosystems that are still part of this larger Ethereum universe, right? So very high level of composability, let's say within Arbitrum lands or within Starknet lands, but between, like, for example, Arbitrum and Polygon, you still have a fairly high level of interoperability, and you still have this really important thing that is shared security, right? So you cannot independently 51% attack Starknet because its security ultimately derives from Ethereum. So this is what Ethereum as a layer 2 centric ecosystem looks like, right? And fees on every one of these cities are much lower than they were on layer 1 years ago. And so where do we go from here, right? So blobs in the future will depend on a technology called data availability sampling. Data availability sampling basically means that you can verify that blobs have been correctly published without actually downloading the full contents of a blob yourself. What this means is that the Ethereum network will be able to remain decentralized while at the same time supporting a much, much higher level of usage than can be supported by each individual node in the network, right? So you will continue to be able to run a node on your laptop. It will actually be easier to run a node over time, but at the same time, the capacity will increase massively, right? So today we have 3 blobs, which is about 375 kilobytes per slot, right? So per 12 seconds. Then the next step is a technology called peer DOS, which gets us up to 8 to 16 blobs. And then finally full DOS, which gets us up to, the medium to long-term target is 128 blobs or around 16 megabytes. So that is how Ethereum scales, right? Ethereum scales through layer 2s, Ethereum scales through blobs, and Ethereum scales through data availability sampling, allowing the chain to process more blobs in a decentralized way. What does this mean for users? Your fees are going to be low, and your fees will continue to be low, and they will continue to be low even as usage increases over time. Now, account abstraction is one really important thing that we've been talking about recently. And account abstraction is this really complicated concept because it combines together a whole bunch of different ideas, right? So the original and I think the most important one is basically that the way that your account gets validated, the cryptography that gets used to verify transactions does not have to just be regular ECDSA signatures, single key, the way that it is today. You can have custom, more complicated verification logic. You can have multiple keys. You can have a recovery key. You can have multiple keys where you need 3 of those keys to sign transactions. You can have a system where you need 1 signature to send small amounts of value and multiple signatures to send large amounts of value. The design space for making accounts more secure increases massively. Then also, some extra side benefits include the ability to use ERC20 tokens to pay fees, to do sponsored transactions, and a whole bunch of things. So really important and really valuable technology here. And as a developer, it's important to know about 4337, to know about some of the discussions around 3074, around 5003, 7560, all of these different EIPs that are trying to enable different parts of this. For a user, this basically just means that in a bunch of different ways, your wallet will become easier to use and it will become more secure. Step number 3, so ZK snarks, right? So this is one, I think, really important and really valuable thing about building applications. And I think it's particularly important actually once we start thinking about like blockchains going beyond finance, right? So ZK snarks basically let you prove things about information that you have without actually fully revealing that information yourself. And this becomes especially valuable for a lot of identity and reputation use cases, because basically, you want to prove that you are trustworthy, but you don't want to publish everything about yourself to some untrusted third party. And you especially don't want to dump all of that information on chain. And so instead of dumping on chain, you can make a proof, and you can prove things, and you can prove some properties of the information that you have, attestations that you have, popes that you have, proof of personhood protocols, without actually revealing all of that information about yourself. And I think a really amazing thing that has happened over the last 5 years is that zk snarks have become massively more developer friendly. So 5 years ago, to make a snark, you basically had to be a cryptographer yourself. Today, we have these very easy to use development environments. So this is ZK REPL. It's zkrepl.dev. You can literally build snark applications inside of your own browser. So it gets pretty amazing. So a huge amount of improvement in our ability to use zk snarks to build applications on top of zk snarks, and generally to build things that support stronger user privacy at the same time as unlocking more functionality and more security. Now, where zk snarks are also powerful as a scalability technology, right? So zk rollups, so Scroll, zk sync, Polygon, Linea, all of these, they all rely on zk snarks for their security. And zk snarks basically let you prove that whatever is going on inside of these systems is correct without actually having to do all of that computation on chain, right? So computation on chain proofs, or computation off chain proofs on chain, and that also makes all of these platforms much cheaper. So that is the value of zk snarks, right? So summarizing all of these things so far, right? So one is that we get much lower fees via layer 2 protocols. We also get much faster confirmations, right? So back before 2020, actually before EIP1559, transactions would often take like 5 minutes to get confirmed. It was crazy inconvenience, right? Then with EIP1559, transaction confirmations reliably became fast, and post-merge, they reliably became faster. And if you are on a layer 2, layer 2s often offer pre-confirmations, and so you often get the equivalent of a basic confirmation in as little as 1 second. So much better UX. So you get to pay lower fees, and things get to confirm much faster, right? And I mean, even 12 seconds is already quite good, right? Because it's already competitive with things like in-person credit card terminals. And then 1 second, of course, is much faster. Then with zk snarks, you get to integrate data both from Web 2 applications and from your Web 3 activity. You get to prove things about yourself, prove that you're a person, prove that you're a member of some community, prove that you're trustworthy based on your previous interactions, do all of these things while preserving privacy. So Ethereum, with all of these things, is really becoming ready for mainstream applications, right? And so one really important last question is basically, where do we go from here, right? And so one big part of the answer here is basically just lower fees will continue, and layer 2s need to continue scaling up. This includes both scaling up data with data availability sampling and scaling up execution, right? Creating much better EVMs. And this is something that I know Ref has been working on. I know Mega ETH has been working on. I know the Geth team is starting to make their node more scalable in a bunch of ways as well. So huge improvements there. Then also interoperability is going to be really huge, right? So we have lots of layer 2s, and we need more, we need the layer 2s to feel more like a shared ecosystem and not like separate universes, right? So you have different cities, and we need a high-speed rail network between those different cities. I think this is already improving. So there's already some new wallets that are coming out. So Rabby is a really a good example that actually make L2s feel like a more seamless experience. And this is improving, right? And we need more decentralized cross-layer 2 trade. We need more protocols for moving assets between layer twos, proving things on layer twos, for ENS to upgrade to be more layer two friendly, for all of the entire ecosystem really needs to upgrade to be much more layer two based right from the start. Then faster confirmations and really being able to take advantage of that and across layer twos will be super important. For the ZK Snark and especially the identity ecosystem, standardization is going to be huge, right? Having the ability to like actually take all these different pieces of information and plug them into each other. Also, ZK identity applications. So there's some interesting ones. Like you can basically make like a non-wrapper around a government ID. And so you can prove that you are a citizen of some country without revealing which one you are. And like that's also super powerful for making privacy preserving applications that simultaneously try to minimize spam from bots and similar kinds of problems. So a lot of really good things happening there. And finally, but like the thing that we need more of, right, is just for all of those different pieces of information, both from Web 2 and from Web 3, to really live inside of a common framework and for to be easy to use inside of a common framework. And so with all of these things together, I think Ethereum can continue to become a more powerful and very easy to use ecosystem that is both very integrated and benefits from a lot of diversity between its different ecosystems, different projects, and different layer twos at the same time. So thank you.